Continuing the series, welcome to this comprehensive presentation on the current state of solid waste management in India. I, Harshit Sinha, as your host, exploring the solid waste management topic of a critical issue in India. The country struggles with the growing volume of municipal solid waste, MSW, generated due to rapid urbanization, population growth, and industrialization. India's waste management systems have not kept pace with the rapid increase in the volume of waste, leading to significant environmental and health challenges. In 2024, the country continues to grapple with the effective collection, segregation, treatment, and disposal of solid waste. This note will explore the current status of solid waste management in India, quantify different types of solid waste produced, and discuss the major issues and challenges faced by the country in managing its waste effectively. India generates approximately 62 million tons of municipal solid waste annually, a number expected to rise to 165 million tons by 2031 due to rapid urbanization and population growth. According to the Ministry of Housing and Urban Affairs, the waste generation rate in urban areas is estimated to be about 0.5 to 1.5 kilos per capita per day. However, only about 43 million tons of this waste is collected, and 11.9 million tons are treated or recycled. The rest ends up in landfills or is improperly disposed of, causing serious environmental and public health concerns. Despite the growth in the volume of waste, India's waste management systems are still largely inadequate. Some Indian cities like Indore, Surat, and Bhopal have made considerable progress in managing waste and achieving better collection, segregation, and recycling rates. However, smaller cities and towns still struggle with poor waste management practices, including a lack of segregation at source and inefficient collection systems. India generates a significant amount of solid waste annually, with municipal solid waste, MSW, being the most common. There are four major types of solid waste, include organic waste, plastic waste, paper waste, and metal waste. 1. Organic waste. Organic waste constitutes about 55-65% of MSW in India. This includes kitchen waste, garden waste, and other biodegradable materials. Only 12 to 13 million tons processed through composting biomethanation. The treatment methods for organic waste include composting, aerobic and vermicomposting, and biomethanation. The Swachh Bharat Mission Urban aims to promote sustainable waste management practices. 2. Plastic waste. Plastic waste is a major environmental concern due to its non-biodegradable nature. India generates approximately 9.46 million tons of plastic waste annually. The Plastic Waste Management Amendment Rules 2018 mandate segregation, collection, and recycling of plastic waste. However, only a fraction of this waste is treated, with the rest often ending up in landfills or water bodies. 3. Paper waste. Paper waste accounts for about 4 to 5% of MSW, that is 9.3 million tons a year, are generated. The treatment methods include recycling and energy recovery through processes like incineration. Recycling paper waste helps conserve natural resources and reduce landfill space. It is estimated that only 27% recycled, which is 2.5 million tons. 4. Metal waste, nearly 4.5 million tons a year are generated. Metal waste includes discarded metal items from households, industries, and construction activities, about 90% recycled through formal-informal sectors. The treatment methods involve recycling and reprocessing to recover valuable metals. Recycling metal waste reduces the need for raw material extraction and conserves. Now, this slides discuss about policy and regulatory framework related to solid waste management. The policy and regulatory framework for solid waste management in India was introduced to address the growing environmental and public health challenges posed by the increasing generation of waste. The Solid Waste Management Rules 2016, Plastic Waste Management Rules 2016, amended 2018, and E-Waste Management Rules 2016 provide a comprehensive framework for the management of different types of waste. The Swachh Bharat mission is a flagship program of the Government of India that aims to achieve 100% sanitation coverage in India. The policy and regulatory framework for solid waste management in India is based on the following principles: prevention of waste generation, minimization of waste generation, reuse and recycling of waste, and safe disposal of waste. The policy and regulatory framework for solid waste management in India has been successful in reducing the amount of waste generated in India. However, there are still challenges that need to be addressed, such as the lack of adequate infrastructure for waste management and the lack of awareness among the public about the importance of waste management. The policy and regulatory framework for solid waste management in India is constantly evolving. The government is committed to improving the waste management system in India and making it more sustainable. This slide discusses the environmental impact arising out of dumped solid waste. Improper solid waste management, SWM, in India has severe environmental and health impacts. These impacts are primarily due to inadequate waste segregation, disposal practices, and a lack of efficient recycling systems. 1. Air pollution. Open burning of waste, especially plastics, releases toxic gases like dioxins and furans, contributing to air pollution. These pollutants pose risks to respiratory health and aggravate existing conditions like asthma. Source: CPCB on air pollution. 2. Water contamination. Landfills often leach hazardous chemicals into groundwater, leading to water contamination. This affects drinking water sources and aquatic ecosystems, posing a risk to public health through waterborne diseases. 3. Soil degradation. The disposal of non-biodegradable waste like plastics in landfills results in long-term soil contamination. Leachates from these landfills affect soil quality, reduce agricultural productivity, and harm biodiversity. 4. Vector-borne diseases. Improper waste management creates breeding grounds for disease-carrying vectors like mosquitoes and rats. Stagnant water in waste piles facilitates the spread of diseases such as dengue, malaria, and leptospirosis. The unchecked growth of waste generation exacerbates these impacts, highlighting the need for improved waste management systems and policies. Effective management can help reduce the harmful effects on both health and the environment. Now, we shall discuss about the challenges related to waste collection and segregation as important mark-through for solid waste management. Effective waste collection and segregation are critical for sustainable waste management, but several challenges hinder these processes in India. 1. Insufficient infrastructure. Many urban areas lack adequate waste collection and segregation infrastructure. This includes a shortage of waste bins, collection vehicles, and processing facilities. The lack of infrastructure leads to inefficient waste management and increased littering. 2. Limited source segregation. Source segregation, which involves separating waste at the point of generation, is not widely practiced. Many households and businesses do not segregate waste, making it difficult to recycle and treat waste effectively. This results in higher contamination levels and reduced recycling rates. 3. Informal sector integration. The informal sector, including waste pickers and recyclers, plays a significant role in waste management. However, integrating these workers into formal waste management systems remains a challenge. Providing them with proper training, equipment, and recognition can improve waste collection and segregation. 4. Public awareness. Lack of awareness and participation from the public is a major obstacle. Many people are unaware of the importance of waste segregation and proper disposal methods. Public awareness campaigns and education programs are essential to change behaviors and promote responsible waste management practices. This slide discusses about what are the challenges in achieving 2024 SWM goals. Achieving the 2024 solid waste management SWM goals in India is hindered by several key challenges. 1. Infrastructure gap. Many cities in India lack the necessary infrastructure for efficient waste management, such as proper waste collection bins, vehicles, and recycling facilities. The shortage of treatment plants and modern waste processing units contributes to the growing burden on landfills. 2. Behavior change. A significant challenge is changing public behavior regarding waste segregation and disposal. The public's lack of awareness and reluctance to adopt waste segregation at the source has slowed the progress of waste management initiatives. Behavioral transformation is necessary for better waste management practices. 3. Technology. Adoption. The adoption of modern technologies for waste management, such as waste-to-energy and advanced recycling techniques, is still limited in India. Many cities lack the financial and technical resources to implement innovative technologies at scale. 4. Policy implementation. Despite comprehensive policies like the Solid Waste Management Rules 2016, enforcement remains weak. Insufficient monitoring, inadequate penalties, and lack of local government capacity to implement these policies impede progress toward SWM goals. Addressing these challenges is essential to achieving the 2024 SWM goals and ensuring sustainable waste management practices in India. Now let us explore what are the financial challenges in solid waste management, SWM. Gradually, it faces numerous financial challenges that hinder its effectiveness and sustainability. These challenges are multifaceted and stem from insufficient budget allocation, high operational costs, limited cost recovery, and inadequate private investment. 1. Insufficient budget allocation. Many municipalities and local governments struggle with limited financial resources. The budget allocated to SWM is often insufficient to cover the expenses required for efficient waste collection, segregation, and disposal. This lack of funding leads to inadequate infrastructure and services, making it difficult to manage waste effectively. Proper budgeting is essential to ensure that SWM systems are robust and capable of handling the volume of waste generated. 2. High operational costs. The operational costs of SWM are significant, encompassing expenses such as the purchase and maintenance of waste collection vehicles, fuel, labor, and treatment facilities. The high costs associated with these operations often exceed the available budget, leading to inefficiencies and cutbacks in services. Moreover, the expenses related to advanced waste management technologies and practices further strain financial resources. 3. Limited cost recovery. Cost recovery mechanisms such as user fees and waste management tariffs are often underutilized or ineffective. Many local authorities do not have the systems in place to collect fees from households and businesses for waste management services. As a result, the revenue generated is insufficient to cover the costs of SWM, leading to a reliance on inadequate public funding. 4. Inadequate private investment. Private sector involvement in SWM is limited, often due to a lack of incentives and regulatory frameworks that encourage investment. Private investors are wary of the high capital costs and long payback periods associated with waste management projects. Without adequate private investment, the burden of financing SWM falls solely on public authorities, further exacerbating the financial challenges. These financial constraints result in inadequate infrastructure, outdated technology, and insufficient manpower in the SWM sector. Innovative financing mechanisms and public-private partnerships are crucial to bridge this funding gap. Addressing these financial challenges requires a holistic approach, including increased budget allocation, efficient cost recovery mechanisms, and fostering private sector participation through conducive policies and incentives. The Indian SWM sector presents numerous opportunities for innovation and investment. Key areas include waste-to-energy technologies, advanced recycling solutions, electric waste collection vehicles, digital platforms for waste management services, and sustainable packaging alternatives. With government support and growing public awareness, the sector is poised for significant growth and transformation in the coming years. Now let us see how technology innovation helps in solid waste management. Technological innovations in solid waste management, SWM, are revolutionizing the way waste is handled in India, offering sustainable solutions to the growing waste challenge. 1. Smart bins. Smart bins are equipped with sensors that monitor waste levels and send alerts when they are full. This helps optimize collection routes, reduce operational costs, and prevent overflowing, improving cleanliness in urban spaces. 2. Waste-to-energy plants. These plants convert non-recyclable waste into energy, typically through incineration or anaerobic digestion. They help reduce the volume of waste sent to landfills while generating renewable energy, making them a crucial solution for managing waste and addressing energy needs. 3. Plastic roads. India has pioneered the use of plastic waste in road construction. Plastic waste is mixed with bitumen to create durable and eco-friendly roads, reducing plastic pollution and providing an innovative way to recycle plastic. Several cities in India have successfully implemented this technology. 4. AI-powered sorting. Artificial intelligence, AI, is being used to automate the sorting of recyclables from waste. AI-powered sorting systems can efficiently identify and separate different types of recyclable materials, increasing recycling rates and reducing contamination. These technological innovations are helping India build more efficient, sustainable, and eco-friendly waste management systems. Solid waste management, SWM, presents numerous investment opportunities driven by the need for sustainable and efficient waste management solutions. Here are some key areas. 1. Recycling technologies. Investment in advanced recycling technologies can significantly enhance the efficiency of waste processing. Innovations such as automated sorting systems and enhanced recycling processes can improve the recovery of valuable materials from waste streams. 2. Waste to energy. Waste to energy plants convert non-recyclable waste into energy through processes like incineration and gasification. Investing in these facilities can help reduce landfill waste while generating renewable energy, contributing to a circular economy. 3. Collection and transportation. Efficient collection and transportation systems are crucial for effective solid waste management. Investments in modern waste collection vehicles, optimized routing software, and infrastructure improvements can enhance the efficiency and reliability of waste collection services. 4. Digital solutions. Digital technologies such as IoT-enabled smart bins and AI-powered waste sorting systems can revolutionize solid waste management. These technologies provide real-time data on waste levels, optimize collection routes, and improve sorting accuracy, leading to more efficient waste management. These investment opportunities can drive innovation and sustainability in the solid waste management sector, addressing environmental challenges while creating economic value. Indore, the largest city in Madhya Pradesh, has become a model for effective solid waste management. Indore's transformation from one of India's dirtiest cities to the cleanest for 4 consecutive years demonstrates the potential for effective SWM. The city's model is now being replicated across India, showcasing the importance of political will, community participation, and integrated approaches in tackling waste management challenges. Though the city's success is attributed to several key initiatives, but 4 are reported key way to success. 1. 100% door-to-door collection. Indore Municipal Corporation, IMC, implemented a comprehensive door-to-door waste collection system, ensuring that all households and commercial establishments are covered. This system uses GPS-enabled vehicles to optimize collection routes and schedules 3. 2. Source segregation. The city mandates segregation of waste at the source, requiring households to separate wet, biodegradable, and dry, recyclable waste. This has significantly improved recycling rates and reduced contamination. 3. Processing facilities. Indore boasts state-of-the-art waste processing facilities, including a 15 MW waste-to-energy plant and a 200 TPD composting plant. These facilities handle 1,000 metric tons of waste daily, converting it into usable products like compost and fuel 3. 4. Sustainable financing. The success of Indore's waste management system is also due to sustainable financing models. The city has partnered with private companies and NGOs to manage waste operations, ensuring efficient and cost-effective waste management. Indore's efforts have earned it the title of India's cleanest city for several consecutive years. The city's approach demonstrates that effective waste management is achievable with community involvement, technological innovation, and strong policy implementation. Now at the end, we will explore what is the future of solid waste management in India by 2024. 2021, ban on single-use plastics and source segregation. In 2021, India took a significant step towards sustainable waste management by implementing a nationwide ban on single-use plastics. This move aimed to reduce plastic pollution and promote the use of eco-friendly alternatives. Additionally, there was an increased focus on source segregation in major cities, encouraging households and businesses to separate recyclable and non-recyclable waste at the point of generation. 2022, expansion of waste-to-energy projects and smart technologies. The following year, 2022, saw a greater emphasis on expanding waste-to-energy projects. These projects convert non-recyclable waste into energy, reducing landfill waste and generating renewable energy. Additionally, the introduction of artificial intelligence, AI, and Internet of Things, IoT technologies in waste management helped create smart cities with more efficient and automated waste collection and processing systems. 2023, electric waste collection vehicles and extended producer responsibility. In 2023, there was a widespread adoption of electric waste collection vehicles, which helped reduce greenhouse gas emissions and noise pollution associated with traditional diesel-powered vehicles. The year also saw the implementation of extended producer responsibility, EPR, for packaging waste, requiring manufacturers to take responsibility for the entire life cycle of their products, including post-consumer waste. 2024, target year for 100% scientific waste management. By 2024, India aims to achieve 100% scientific waste management, ensuring that all waste is processed and disposed of in an environmentally friendly manner. This target includes a significant increase in recycling rates and a reduction in waste sent to landfills. The focus is on creating a circular economy where waste is minimized and resources are reused and recycled. The future of solid waste management in India looks promising, with continuous advancements in technology and policy. The integration of AI and IoT will further enhance waste management efficiency, while the expansion of waste-to-energy projects will contribute to sustainable energy production. The commitment to EPR and the adoption of electric waste collection vehicles will play a crucial role in reducing environmental impact. As India moves towards its goal of 100% scientific waste management, the emphasis on recycling and reducing landfill waste will become even more critical. With ongoing efforts and innovations, the country is on track to achieve a cleaner and greener future. Well, here comes the end of the presentation, and before we proceed to the next topic, let us have an overview of today's presentation. In the beginning, we introduced the topic of India's solid waste crisis, a challenge for sustainable solutions, followed by the scale of India's solid waste challenge and the types of solid waste in India. This is followed up with the narration of policy and regulatory framework and the related impact of solid waste management. Later, what are the challenges related to waste collection and segregation challenges are discussed in brief. This is followed up with a description of the challenges in achieving 2024 solid waste management goals, which is also followed up financial challenges. While ending the presentation, we discussed opportunities in India's solid waste management sector with technology and pointed out investment opportunities in solid waste management. A success story of Indore's solid waste management with future outlook of solid waste management in India by 2024. So stay tuned till next week when we dive into new types of waste management challenges related to plastic waste. Till then, enjoy planning your Christmas vacation.